All right, so this lesson was kind of 3 parts. We're talking about end behavior, zeros, and multiplicity. So we're now on to our zeros section. Now, zeros is an interesting word, and it's a word in math that we actually use a lot of different words to represent zeros. So we actually used this in last lesson in 7-1, but we called them solutions. Sometimes you're going to call them solutions. Sometimes you'll hear them called roots. Sometimes you'll hear them called, this is most common, is x-intercepts. So those are just fancy words for these zeros, but what it means is it does mean the point at which the function intercepts the x-axis right here. So here's your x's, here's your y's. So these are what we call x-intercepts, or we're going to call in this unit zeros right here. So just note this function actually has 3 zeros. Sometimes they'll have 2, sometimes they'll have 7. But you're just looking anywhere where that crosses that x-axis is considered a 0. If you've got a polynomial that has degree n, so n is just a generic for whatever degree it is, it can have at most n real zeros. So if your function is degree 3, then 3 is the most zeros you can have. If it's degree 7, then 7 is the most zeros that you could have. So just look out for that. We'll talk about that as we go along. If you have an even polynomial, just note that you'll have an even number of zeros. Most of the time, you'll just have the same number of zeros as the degree. But we're going to talk about some special cases today. And an odd degree will have an odd number of zeros as well. Okay, so to find zeros, because that's going to be pretty important in our lesson today. But basically, this is just like our 7-1. We're going to solve. So the solutions, if we're talking about last unit, the solutions to the equation, when we set it equal to 0, those are what we call the zeros. They're also called, let's put zeros. Again, they're also called roots. They're also called x-intercepts, but the solutions and zeros is what you're going to consider. Now, if you've got a solution to the equation, then you can write it as what we call a linear factor. So here you're going to write, let's turn this color to orange. Linear factor. A linear factor just means that you've got x to the first power added or subtracted to that solution right there. Okay, so what you're trying to do to be able to find the zeros is you want to factor everything into what we call linear factors. You want to be able to write it as x minus 3 or 2x plus 7, something with just an x in there. So, and we do that by factoring. So this is just like last lesson. So these 3 examples, you're going to do the same steps. We just don't have the equal 0 that we had before. But remember, once we got it equal to 0, then we factored out our greatest common factor. In this case, notice how they all have an x. So we're going to factor or undistribute out our x right there. And then we're just going to figure out, what do you multiply x with to get x to the third? Well, x squared. What do I multiply x with to get 5x squared? 5x. What do I multiply x with to get negative 24x and a negative 24? Okay, so far we've got a linear factor. Now, it doesn't really look super like this, x minus c, but you do have an x minus 0 right here if you want to kind of think of that as your c. So we've got one linear factor, but we're going to try and turn this trinomial into 2 more factors. So remember, we want to keep factoring. We want to see what 2 numbers multiply to negative 24, but they add to 5. Oh, and our first terms here have to multiply to my x squared. So if I have a positive 8 and a negative 3, then remember, when you check everything in negative 3x plus 8x, that gives you the 5x. Okay, so now we have what we call, this is written in what we call factored form. Okay, so I've got a factor, and a factor right here. So we'll put down this f of x. So a lot of times, instead of graphing it like this, we like it graphed right here, because then I could see where these x-intercepts are, where my lovely picture crosses that x-axis. So we like the factored form to help us identify the zeros right here. It does want us to identify the zeros. So again, I think it's a lot more important to write it in factored form. I would write this like this. That was our write it as linear factors. But now to get the zeros, you're just going to say, what gives me a 0? Well, 0 would give a 0. -8, this is just like last lesson, just set them each equal to 0 and you've got it, and a +3. Okay, so if we were graphing this, whoops, I don't want to go up that far. If we are graphing this, kind of use the same thing here, you'd have a 0 at 0, it would cross at 0, it would cross at -8, and it would cross at 3. Okay, all right, let's try this one. We're going to, first of all, factor. Notice x here is my greatest common factor again, just like this one. I'm going to factor out an x, and I'm left with 2x squared minus 5x minus 3. All right, so this is another lovely trinomial, and it's your favorite one to graph because it is a guess and check. Okay, you've got to guess here, and you've got to say, well, my first terms here have to multiply to 2 this time. Notice over here is just x squared. We didn't really have to do any guessing. 2 is not too bad, though, because the only way to multiply numbers to 2 are 1 and 2. So I've got a 1x and a 2x. My last numbers have to be 1 and 3. So the only guessing I really have to do is, do you put 3 here or 1 here? So I'm just going to look at it. I can kind of see this, and I'll show you how I would check it, though. Remember, you've got to check that your outside terms is 2x times 3. That'll give me a 6x. And the 1 times x, which gives me a 1x. Now, that I can make into a -5. If I turn this 6 into a -6 and the 1 into a +1, then 6x plus 1x will give me that 5x right there. Or I guess I should be pointing at this one. That one was squared. So this 5x. So that's what I want to do. I want to make this negative right here and this one a positive. Remember, don't use 2 and 3 because then they, if you try and put the 3 here and the 2 here, that would add to 5. You want to make sure that they're different signs. They've got to subtract. Okay, I'm going to erase our checking. We checked it and it was completely correct. But this is what we call factored form. In fact, let's just throw that f of x out here. This is factored form. This is going to be helpful because if we were to graph this, we would know 3 points on my graph. I know my 3 x-intercepts. Again, one of them is just 0. This one, remember when you're setting these equal to 0, 2x plus 1 equals 0. This is when you have to subtract 1 from both sides. So 2x equals -1 and then divide by 2. So -1/2 is the solution and then a +3. Those are my 3 zeros right there. Guess we'll underline those zeros too. All right, let's look at this last example for this video. We are going to factor this. Now this one, there's not a greatest common factor. Notice there's no x in my last term. I cannot factor out an x. There's no numbers here. So we're going to factor this into our 2 binomials. Now this time, remember, our first and first have to multiply to this x to the 4th. Our last numbers have to multiply to 4. But so these are numbers. So when we add our numbers together for our inside terms, they've got to add to that x squared. So this middle term right here just basically tells you what your first term is going to be when you have the 2 binomials. All right, now we're trying to find 2 numbers that multiply to a +4 and add to a -5. Well, -4 times -1 is +4, but when you add them together, you get the -5. All right. Now, this is not what we call, this is factored. We factored it, but it is not what we call a linear factor. Linear means you've got x to the first power. So you want to check to see if you can go any farther. See how these all got down to x, x, x. They're all x's. We don't want this x squared if we can help it. Sometimes we can't help it. But notice this is a difference of squares. It tells me that's a square. I know 2 squared is 4. So this is a difference of squares, which means I can factor that into my conjugates. Remember the plus and the minus? Then you just say, what's the square root of x squared? Well, it tells me it's just x. What's the square root of 4? Well, 2 times 2 is 4 right there. Okay, so this one went to those 2 binomials. Now, this is also this lovely x squared minus 1. It's also a difference of squares. Okay, so we can factor this into the plus and minus as well. X squared goes to x's, and 1, the square root of 1 is 1 right there. So this is now what we would say in linear factored form. We've got 4 zeros. Okay, we love it to be able to write it like this. Again, it's so easy when you go to graph it, which we're going to be doing later on. But you're going to go ahead and say, all right, this means -2. -2 plus 2 is a 0. Also a positive 2. 2 minus 2 is 0. Negative 1 is a 0, and a positive 1 is a 0. So you got 4 lovely zeros right there. All right, so far we've talked about end behavior. Now we've talked about zeros. Our next video, we'll talk about multiplicity.